Hi everyone, welcome back to Logic Stored. In today's session, we are going to explore one of the most important concepts in Snowflake, the Snowflake Architecture. We will learn how Snowflake stores data, how compute warehouses processes queries, and how the service layer manages everything behind the scenes. And finally, we will move to a hands-on lab to see all these layers in real time. Let's get started. Snowflake is a cloud-based data platform that supports data storage, processing, and analytics all in one place. It's fully managed, serverless, and available on AWS, Azure, and GCP. What makes a Snowflake different is the separation of storage and compute, meaning your data lives in one place, but you can spin up multiple computer clusters to process it independently. This gives scalability, concurrency, and cost efficiency. Snowflake's architecture has three key layers: storage layer, compute layer, and cloud service layer. Let's understand each one in detail. The storage layer is where all your data is stored. When you load data into Snowflake, it automatically converts it into micro-partitions, compressed columnar blocks of data. Each micro-partition is immutable and fully managed by Snowflake. You don't manage files or indexes. Snowflake handles that internally. Physically, your data is stored in cloud storage such as AWS S3, Azure Blob, or Google Cloud Storage. Even if you delete or modify data, Snowflake can recover it using time travel. Next is the compute layer, made up of virtual warehouses. Each warehouse is an independent compute cluster that executes queries and transformations. You can have separate warehouses for ETL, reporting, and ad hoc analysis, all reading from the same shared storage. The best part is, warehouses can be scaled up to get more power or scaled out to handle concurrency. You can also pause and resume warehouses anytime, and you pay only when they are running. The cloud services layers act as the control plane, the brain of Snowflake. It manages authentication, access control, query parsing, optimization, metadata, and transactions. It ensures your queries are optimized and executed efficiently by the compute layer. So overall, storage holds your data, compute processes it, service manage the whole system. Now let's see how these three layers actually work in Snowflake. I'm already logged into Snowsite, the Snowflake web interface. Let's start by selecting our role, database, schema, and warehouse. This setup connects our session to a specific warehouse. Remember, that's part of the compute layer. Now let's create a simple table called sales. When this command runs, Snowflake allocates metadata inside the cloud service layer and prepares storage space in the storage layer. Let's insert some sample rows. These rows are now automatically stored as micro-partitions inside Snowflake's managed storage. You don't see any files or folders. Snowflake abstracts everything for you. Let's query the table. The query is executed by the virtual warehouse. If I pause the warehouse and run the query again, it will resume automatically. That's auto-resume. Notice the data stays in storage even when compute is passed. That's the true separation of storage and compute. Now let's check table metadata. The result you see here is not fetched from the data itself. It's stored in metadata managed by the cloud services layer. You can optimize cost by setting auto suspend and resume. This means the warehouse will automatically pause after 60 seconds of inactivity and resume when a new query runs, helping save credits. So that's a complete Snowflake architecture. Storage layer stores data in optimized micro-partitions. Compute layer executes querying using independent warehouses. Cloud services layer manages metadata, security, and query optimization. We also saw in our lab how data remains in storage even when compute is off, proving the separation of layers. Thanks for watching Logic Stud. Don't forget to like, share and subscribe for more Snowflake and data engineering content.